All right, this is section 2.2. We are talking about the algebra of functions, and this is part 2. We're going to talk specifically about the difference quotients. And if you take a look at this, you'll see a couple things. First of all, we have our x and our y, or f of x and our f of x, and then we have a little bit more than our x and a little bit more along the way of our f of x here with our f of x plus h. All right. So if you take a look at this, here we have a secant line. This blue one here is a secant line. And it's going to, if you look at it, we're being asked what the slope of this line is. Okay, we don't worry about the extra curve, and we're looking only at the individual 2 points. All right, so we can be really off by doing that. There's another, I mean, if we were to go the other direction, we could have something, curving like this. And if you were to pick this point and this point, you could very much overestimate, right? You could overestimate this by this amount. Here we're underestimating by this amount. Okay, so when we have a large h, which is the difference between our x and our next x, right, our x plus h, we tend to have the possibility, and in fact the probability, of being too high or too low. When we are talking about the tangent line, we are talking about being right up against the curve, and we're talking right there. So the difference is going to be so minute. Our actual slope of the line right here is going to be much more precise than the slope of the line here because of the overage or the underage that you're going to have. With our function, if you take a look at this, right, this is our y2 minus y1 and our x2 minus x1, right? So this is only going to leave us our h at the end, which is the difference between those two. And here, again, we're looking at this is really our slope function, right? This is our slope. And it's real easy to kind of lose track of what's happening because it's a new looking formula. Well, it is, but it's not. It's the same formula, except we're using different letters, and we're talking about it in a different context. Here, we're talking about the difference between a large h and a small h. And depending on how big or how small that is, the more precise we're going to be. Okay, so here I'm going to go ahead. I have two points that are given. I have 40 and 600, and then I have 41 and 622.50. So here, if I take my 622.50 and I subtract the 600 from it, and then I'm going to have my 41 minus 40, I'm going to have 22.50 over 1. Now what does this mean? If I were talking about hours worked and gross pay, this is a full work week. 40 hours is full work week. Okay? 41, now you're starting to work more than a full work week. So they start having to, take a look at convincing you to do this. All right? And one of the ways they do that is with overtime. So here, instead of having our $15 per hour, which is what this would be, right, you're going to wind up having more money. They're going to have to pay you $22.50, which is an increase of $7.50. So it's time and a half, right? So here we're talking about an increase in order to try and give you an incentive to work some extra overtime. Some places have mandatory overtime, and sometimes if you don't do that, then you wind up looking for a new job. But a a lot of places have found that that doesn't work so well. If you can get people to volunteer for the overtime, then they are much more likely to do it on their own and feel much better about it. All right, so some information regarding the relationship between hours of sleep and grade performance. I know for a fact that this is very close to accurate as far as middle and high school students. If a student slept for 6 hours, the work performance was at 65%. All right, so my 6 is my independent, and 65% is my dependent variable, or my x and my y if you prefer. And then here, if I have 8 hours, you're going to have 85%. So between these two, you have a significant difference, and it really is this extreme. People that are have not had enough sleep, are under-rested, tend to have a much harder time academically than those who are well-rested. So in this case, again, I'm going to take my 85, and I'm going to subtract the 65. And here I'm going to have 8 minus 6. And so that's going to give me 20 over 2. So we're saying about 10% gained or lost for each hour of sleep you either get or you don't get. So that's a pretty significant amount. This also, if you stop and think about it, this is actually a fairly large difference, you know, in terms of my 8 hours, and that's 6 hours. When we're talking about small numbers like this, 8 and 6, the 2 is actually going to be a significant portion. So in that case, this is going to be more like the curve that we had where it was doing this, right? And we had an amount that was probably over for some people. There'd be more, some people would do better, other people would not. Where if we're talking about the gross pay, right? Here we're talking about something that does this, right? Just touches. Oops. Where did I go? So this is going to give you your difference here of a smaller amount. So if you have a smaller amount, this is a much bigger difference, right? This is big as opposed to this one. This would be, I mean, 2 down here is 25% of your amount. 40 and 41, that's, I mean, it's definitely not a huge amount comparatively. So it's sort of the difference between whether or not we have the secant line, which is this blue one, compared to the tangent line. So how close we are and how accurate depends on how refined we are in our measurements. All right, I think I'm going to call this good, and we're going to move on to 2.3. Yep, okay, so we're going to move on to 2.3 in our next video.